Hey, good morning, everybody. Morning. Thank you for showing up here. Hey, I really appreciate it. It's the last day. It was a busy week, and you're still here. I think that many people already left or are now at the airport. And so I really appreciate it that you're here and join me for this session about desktop virtualization and session remoting. I don't work for Microsoft. I'm independent. I'm an independent consultant. And I'm a Microsoft Most Valuable Professional. I'm a member of the Microsoft Regional Director Group. I'm also an NVIDIA Grid Community Advisor and a Citrix CTP. So I belong to these community programs, giving me access to the development teams and the program management within these companies. I'm also a VMware EOC expert, so I also belong to the VMware program when it comes to remoting, not the hypervisor. It is the EOC program, which is fairly small. There are only like 30 people globally that are in this program, and that gives you an idea that this is an emerging market also for the VMware folks. As I said, I'm independent. I'm specialized in designing RDS infrastructures, and I'm doing remote desktop benchmarking and monitoring. So one of my biggest customers, and they paid a substantial amount of my time, is Lakeside, and they're doing monitoring. So I have the opportunity to go to many customers in their name and monitor their environments and build POCs using Lakeside SysTrack. So I will not be pitching the product. Don't be worried. Like I said, I'm independent. And we are working in the community because it's too much that's going on in this industry that it's too much for one person. So we created two community teams. One is Team RGE, the Team Remoting Graphics Experts. So we concentrate on GPU-accelerated remoting, no matter what the remoting platform is. It goes across the vendors. While RDS Gurus, as the name indicates, concentrates on RDS-only infrastructures. So these are the two community groups that I belong to. And I will introduce you some of the members. And since this is a software company that develops the tools that we need for that, so we live DevOps. So we have developers, they are in Hungary, and they develop the products that we have. So here you see my email, my Twitter handle. So just reach out if you have questions after my session. Good. Like I said, it's 10 people who contributed to this session. So I'm like the anchor of a news show. And I'm German, so it's going to be like a news show. It's not going to be a fun session. We don't get the concept of humor. So the team, oh, look at that. The Germans are laughing about that. So it's an international team from the US, Netherlands, Canada, Germany, and Norway. So the first, like Chris, Frake, Ruben, they are the members of Team RGE and RDS Gurus, while the others, they contribute with their tools, with their ideas, with their, with their best practices from the field. So, and the one who developed the tool that you have seen previously, that was Bram Wolfs. So he was the one who developed this little remote desktop display manager that you've seen, and you will see it later again. Here's the agenda. I will give you a short intro into RDS 2016. There were so many good sessions there about RDS 2016, so I will not dig into that. So if anybody is in the room who doesn't know about remote desktop services, this may be the wrong session for you, because I will not go into the intro things. We're going to take a look at the architecture, deployment best practices, and then the messages and the things that we learned from the field. First of all, admin experience. The next thing is security. And then, like I said previously, GPU acceleration, network impacts, and how are you doing monitoring and benchmarking in such an environment. It's not easy. That's the recap slide. Like you've seen that before. Session-based computing and virtual desktop infrastructure are both possible both on premises and in the cloud. And Microsoft has introduced some innovations with Server 2016 when it comes to RDS, increased performance, in particular graphics improvements. The scalability is better, the connection broker is better, and it's optimized for the cloud. So this is something that we will cover throughout the session. Now, the question that I get always asked, why are we still doing RDS? Isn't it a dead technology? As a matter of fact, I look at it from that perspective that Windows is not something that gives me a desktop with certain tools. I rather look at it as a runtime environment for applications. That's all it is. So what the applications do, they take advantage of communication infrastructure that is built into the Windows operating system, no matter if you look at the desktop or you don't. So you have some of the newer concepts to do communication, and you have some of the legacy concepts. But many applications are out there that still rely on these legacy communication mechanisms that are built into the OS. And the same is true for the graphics formats. I mean, we still have GDI applications. I developed applications 10 years ago, 15 years ago, and they still run on the modern versions of the Windows OS. So it's backward compatible over a very, very long time. So we will still have many applications out there that are using exactly these graphics formats. GDI, GDI+, DirectX, Windows Presentation Foundation, OpenGL, you see them. You see there are some that are kind of retired, like Silverlight and Flash, but you find many of these applications out there. So this is why it's so important that you orchestrate your existing application base that you have in most enterprises on the Windows runtime. Mobile apps and web apps, in most cases, cannot replace so easily conventional Windows applications. Individually, yes, you can migrate one individual application, but if you have an entire workflow with multiple applications, it's extremely hard to migrate them all to a new platform. And this is why so many customers are still using Windows applications, and this is why RDS is still relevant, and it will still be relevant in a couple of years now. And I will cover why this is the case. Because I did, T-Systems in Germany, they asked me to co-author a white paper about the digital transformation or workspace transformation. And these are the guys that are running the German Azure cloud. And they wanted to know, hey, is a workspace transformation something that will only use web apps and mobile apps? And when we wrote the white paper, we found out that all the different market segments, they're still heavily using desktop applications. So, like I said, they're not going to go away anytime soon. Maybe it's only a transition solution, but the transition may take a while. Because we have what we call the long tail, which means what is the adoption rate of web apps and mobile apps? If you look at it, this is the curve. And if you look above the curve, this is, well, these are the applications that are web-based or mobile, while below the curve, these are the Windows applications. Okay, we are at most customers in this phase, in this green phase, where applications, Windows applications rapidly decline from a percentage perspective. So at many customers, we have like 70, 60, 50% Windows apps, and the rest is web apps, mobile apps. Fine. So we're still in this green phase. But, I mean, technologies like Docker, they will influence this curve massively. No question, no doubt about that. And then we will be in a phase where we have between 50 and 15% of Windows applications. But if it's the relevant Windows applications, hey, we still have a job to do. Only if we have this long tail, the acceptance of web and mobile platforms are the dominating technologies being used out there, we have this long tail. Then we are the hosters. The terminal server RDS guys are the modern hosters. The guys that we had in the 80s that were responsible for the IBM hosts and maintained them when we saw the emerging client-server technology. Okay, so that's fine. So I would say the yellow piece, that's going to be the next 5 years. The red one, I don't want to predict that. That could be 10 years, that could be 20 years. That's a good question to ask. How long is it going to take until there's the last Windows application? I have a good friend who said it's going to be cockroaches and Windows applications that are going to be left if there's a major disaster on Earth. Good. So what are the benefits? I mean, most of you know that. You move the applications that are running locally to the data center. They are running on an RDSH server or RDVH server. The application runs in the data center, and you connect to the application through a remoting protocol. So the data center has the advantage: control, efficiency, cloudification, security. At this moment, I want to say just putting RDSH and RDVH machines into a data center is not security. Not per se, not out of the box. You have to add additional components to make it secure. But it's a first step. It's a consolidation work that you're doing, and it allows you to apply better security concepts, because then you can use all the different client platforms in the world to connect. This is the story. I'm using this for the first 30 seconds when I'm talking to customers. Do you know what RDSH is? This is it. Okay. After we have that, this is the general architecture. This is only for the names: RD Connection Client, RD Web Access, Connection Broker, Session Host, Virtualization Host. Very often I still refer to RD Session Host as Terminal Server and to RD Virtualization Host as a VDI environment. It makes it easier to differentiate between the two, because sometimes I get confused by the acronyms. Then you have the RD gateway, and you do some authorization checks and and security measures through Active Directory. So this is the base architecture. Now, when we build those architectures out there, and this is an example from one of my customers that I have. So this is an on-prem RDS environment. This customer has 4 massive physical machines running a Hyper-V cluster. On top of this cluster, they are running in total like 60 virtual machines, and like 4 of them are the RDS Session Host collection. So 8 cores, 20 gig of memory. This is sort of their base platform that they're using. On top of that, SQL Server and Remote Desktop Connection Broker in a high availability setup. So you add 4 more virtual machines on top of that. Then you want to have the domain controllers and DNS and file servers. Those are 2 machines, again, to have some HA. And this particular customer, he connected his NetApp cluster as a storage platform. But this is something that looks very different at every customer. Every customer has a different priority, what they want, or preference, what they want to use. And the clients connect through the connection broker, and the automation is done by PowerShell. This is a typical setup that we find at customers. So nothing fancy. It takes a while to put it together. The automation is the critical piece. So you see there's PowerShell for the automation, because everything that is exposed through the management console, you can do through PowerShell. Good. Now let's do the same thing as IIS. Here, we don't need to care about the hypervisor. We just create the RD Session Host collection. It's Azure VMs. On top of that, we started with 1 connection broker because we want to go cheap at the beginning. We added, again, the domain controllers, and we added disk space. At the beginning, this customer wanted to use DFS, failed miserably. Don't use DFS on Azure. Doesn't work. So we recommended to use storage spaces. Well, that was the way to go. Today, it's Storage Spaces Direct, what you would use when you built the same environment. This is something that we built like 9 months ago. So Storage Spaces Direct was not available at the time. So this would be the natural thing to migrate to Storage Spaces Direct. Now, we wanted to make sure that the users can connect, RD Gateway and Web Access Servers, again, 2 VMs, and hey, high availability was added at a certain stage of the project to make sure that the system doesn't fail. Good. Now we were using Azure Resource Manager for the automation. So this is the new style. The clients connect through RD Gateway and Web Access Server, and the authentication goes through AD domain controllers and with federation, because they wanted to connect their local AD with the Azure AD. Okay, so this is a typical blueprint how you do that. Good. Now, 2016 allows us to consolidate more services, more roles on one VM. That's good. So it allows us to reduce the number of VMs that are required. Plus, Microsoft decided that, hey, running a SQL Server cluster just for like the 100 megabyte it requires to do the load balancing, maybe we should reduce that and allow the connection to a SQL Server database that is hosted on Azure. And this is what they did. So you can use Azure SQL DB, and they improved massively the performance of the connection broker. And all the automation, like I said previously, is done through Resource Manager, Azure Resource Manager. There are these templates out there. Microsoft started creating all these templates. But the thing was that our friend Frank Berson, who is part of RDS Gurus, he decided, hey, why not take one of those templates, use it as a starting point, but then go to one of my customers, look at the on-prem installation that this customer has, and create a template, a custom template that reflects exactly what the customer has and propose it as a migration scenario to this particular customer, because he can try it out. He can just spin it up in less than an hour, try it out and see, hey, okay, it works like I expected it. So he's using JSON, a JSON template to create storage account, availability sets, NICs, joins the domain, the load balancer, fixed IP addresses, the Azure SQL database. That's something that he's using here. Full AJ, including a wildcard certificate. 2 session collections, one for the desktops, one for remote app. We had this conversation previously. And all credentials are being stored in Azure Key Vault. Now, this is what he did, and our initial plan was demonstrating that, but to be honest, wow, this is tough. So we created the video, how he does it. He opens the Azure portal, he selects the resource group that he's using. So now you can see that there is a domain controller that's already there, because that's the case for most customers, and a virtual network. That's the only prerequisite that's out there. Now he's using that. He switches over to his Visual Studio. Oh my God, Visual Studio in an IT Pro session. Yep, that's what you do if you develop JSON templates. So you see here are the JSON files, 2 deployment files. One is for the parameters, the other for the logic. Now on the left side, you see the parameters that are used, the variables, and the resources that will be created in the next step. So after you have all that together, it doesn't take more than to deploy this environment. And this is what he does. He starts this deployment. New deployment, now the dialog box pops up, and you can provide the necessary information. What is the subscription? What is the resource group? And you can edit the parameters if you want to go into details, like it creates 2 connection broker machines, 2 gateway machines, 2 RDSH machines. And here is the setting for the Azure SQL. So he injects the string for the Azure SQL. And then he says deploy. And everything starts rolling. Wonderful. So this takes roughly 40 minutes until everything is set up. At every point, you can take a look at what the situation is in the portal, in the Azure portal. This is what he's going to do next. Taking a look and refresh here, and you see all the resources, all the objects are being created. Okay, so good. So far, so good. Now, after 40 minutes, you take a look at the environment. Okay, what we have here, We have successfully deployed it. We have the web access URL. And now we're just going to use this environment. Yeah, you see everything is in AJ. It shows all the objects here. They are up and running nicely. Now opening another browser window, and you see the certificate. Yes, it's a proper wildcard certificate that's injected in here. Wonderful. And now we can take a look at the management UI. Well, he logs on as a test user first. And you see that there is a desktop and there's published applications, remote app applications out there. And as I said previously, it's 2 collections, 1 collection for the remote app programs and 1 for the desktop. So you see it here. First of all, yeah, everything is in AJ. 2 machines of each kind. And then looking at the collections. Good. So that's what it looks like. That is very impressive when you do that in front of a customer. Because you analyze his entire environment that he has as of today, you create something like that, it takes a while. And there is a blog article that was published by Freek, so that you can look it up, and we're planning on also publishing the videos so that you know how it works. That was nice work done by Freek, and I'm really happy that he did it. It took him a couple of weeks until he came to that point and understands, but now we can offer that service to our customers quite easily. So that is an easy migration path for them. They know what they get. So now going to go to the field. The first thing is admin experience. You have seen the user interface of our beloved server manager. I truly believe that was an accident, and I hope it's going to go away anytime soon, because it is nice on the first glance, but if you use it on a daily basis, it's painful. So, because the thing is, you need on one side the stuff in order to configure RDS, and on the other side, you need the management. That's something that you do on a daily basis. And you should separate those 2 things, because you create the environment once, and you may want to change it after half a year, but then you want to maintain stuff on the other side. And you want to separate those 2. And this is sort of the collection of the tasks that we found out when asking our friends in the community. So what is it that you need to do RDS configuration, and what is it to do RDS management? So I don't want to go through this list. You can all read it, but it's very obvious what the difference is. Good. So there are third-party RDS management tools, and they are all developed by community fellows. Christian Troll in Germany, Claudio Rodriguez in Canada. They created OneGlass. And Remote Desktop Commander by Andy Milford. He's also an MVP, an RDS MVP. He's here from Atlanta, and he developed the Remote Desktop Commander. So I have screenshots. OneGlass, this is what it looks like. The idea behind OneGlass is that you're using PowerShell scripts and you create a nice user interface around it, so that if you, as a consultant, you create the PowerShell scripts and you leave it behind at the customers, that the customers don't break them. So you give them a UI. That is the idea. We don't want customers to play around with our PowerShell scripts. We want to hide the PowerShell scripts. And that is the idea behind this tool, while Andy Milford created a little bit more an application to do the daily management, like what are my users doing? So how can I make sure that they get the best user experience? So this is a standard WinForm application. And what I have here is, again, 2 videos walking you through some basic steps. Yep, here it is. OneGlass first. So it's a fairly simple thing. Here we want to make sure that our RDS web access has, a customized icon. So we run the PowerShell script that sits behind that. And we go back to the web page. We do a refresh, and look at that. It's skinned. That's wonderful. This is what our customers want to see. So this is, like I said, it's simple PowerShell scripts that are behind the scenes. And now we want to create a new collection. You need to provide some basic information, like, okay, this is the name of the new collection, this is the server, it creates it, PowerShell script, and here we go, you have the collection, and you can modify all the settings interactively now, again, only using PowerShell script. Claudio Rodriguez, he developed all the PowerShell script logic, he is the RDS MVP, and Christian Troll, he built the framework around it, and the two, they work together. This is the idea, community work. Yeah, they will release it quite soon. So this is something that we're working on together with the RDS team. That's an interesting thing to just share with you. Then RD Commander is more like daily management, my users, I want to check out what they do, the IP addresses, the client build, I want to see how long they were logged in and what they were using, what kind of resources they were using. You want to see like latencies and information about the protocol. You want to go and see which are the applications that are consuming the most resources on one of my servers. You see peak memory and peak CPU. So these are the things that you can analyze with RD Commander. And you can drill into individual users. There's one user that consumed too many resources. We want to find out why this is. We go to a certain point in the history and see what the applications were that the user was using. He takes screenshots so that you can see what was on the screen when the user generated the high load. You want to identify the noisy neighbor. So this is what this tool is about. And you want to generate reports because you want to tell your management, hey, I need new servers because I have these noisy neighbors and this is what they do. This is basically what it is. And it all uses the standard APIs and the standard PowerShell scripts and commandlets that are provided by Microsoft. And we're just using it, putting a shell around it. So that is the basic idea behind those management tools. I just wanted to make sure that you understand that there are tools out there that go beyond or that are an alternative to the large management tools that come from Citrix and Ericom and the like. So typically, it's the smaller customers that want to use those third-party tools that fill that particular niche. Good. Let's move on. Security. Because one of the requirements that my customers have is, hey, my users have unmanaged clients. Now, if they connect, I want to make sure that their client is configured to be compliant to what I want it to be, but I don't have control over this client. So what can I do? I have an unmanaged endpoint, and now the user decides that he wants to change something that is kind of stupid from an enterprise standpoint. And I want to mask the applications. I want to hide the applications so that the user doesn't have access to those applications anymore. That is the general idea behind context awareness and application masking. And it's two tools that are behind that. One is Device Trust. It's a little startup, and they're specialized on finding out what's going on the client, and they send the information down a virtual channel to the remote session. They're able to look at 150 different parameters. And you can decide what to do. Like if your users are walking from one network segment to the other, you want to do something. You want to change some of the configuration. And this is what they do. They provide the triggers and those parameters, those properties. It's used for security, compliance, performance, user experience, whatever you want to do. On the other side, we have FS Logics, and they do application layering and masking. And the other thing, what they do is they are able to handle Office 365 OST and PST files in remote desktop environments, which is a painful thing. So this is what they're specialized in. Now, if we want to take a look at what the impact is for a customer, I asked them to re-implement it on Server 2016, what they have done in previous versions of RDSH at customers. And I recorded that. The first thing was, let's stop it here. I'm on a Windows 10 machine as a user, unmanaged machine, and I connect to a 2016 RDSH machine to my session. This is what this user is doing. So you see here, I'm user Benny, and then I'm connecting. Now the connection is done. Adam 1 is the user. This user is logged on now. But now I decide to do something stupid. I just turn off the firewall. I turn off the firewall, and look at that, what happens. Woo, nice. Now the remote session is blocked because that was the rule that was applied. If the user turns off the firewall, don't let him access the remote session. That was the idea. Okay, so now you get the idea. As soon as I decide, okay, I'm going to turn it on again, fine, okay, back. So that's what my customers want to have. Now, like I said, we want to go one step further, and instead of just blocking the user out, we want to mask applications. Now, we are using another user, Berta, and she logs on, and the rule behind her as a user is if she modifies the firewall settings, we want to hide, mask the applications. Here are her most critical business applications, Notepad and all that. So we also take a look at the file system. And now again, we turn off the firewall. Boom. In the file system, in the registry, the icons, gone. The user cannot see these applications anymore. I turn on the firewall, and they're back. That's the idea. That gives you some security control. Like I said, just creating RDSH in a data center is not security. You need to add stuff. And this is one of the options. I just wanted to demonstrate what the little things are out there that customers are asking us to do. Good. So that's FS Logics and Device Trust. It's interesting. These are startups. And again, people from the community. People that I know since many years, and they have the same sort of customers that I have. And we had this conversation all the time. And so Device Trust, they are experts in writing filter drivers. This is basically what's behind the scenes. It's filter drivers, pretty much like in the early times, Regmon and FileMon, and today Process Monitor. It's invented by Mark Krasinovich. It's the filter drivers that are behind the scenes that are doing the job. It's a little bit like reverse application isolation, because instead of giving users access to isolated applications, it's blocking users from isolated applications with filter drivers and configurable filter drivers. That is the idea. And like I said, the other device trusting is sending those properties through a virtual channel and making sure that the triggers are initiated that make the change. Good. So coming to the final section of this presentation, which is going to take a little longer than the other two from the field because it's about GPUs, it's about user experience, which is improved by using GPUs, and how to monitor it, how to find out what is good user experience. Because if you do a survey within your user base and you ask them what is good user experience, you will not get a good answer. So we had a vendor in the sports industry, one of those two vendors in Germany with the sports shoes. And it was interesting because they did a survey right after the World Championship in soccer. And their CIO, she was judged by the happiness of the users regarding user experience. And they had done the same survey a year before. And they did the new survey right after the World Championship. And guess what? Results were 30% better. Because these people were so happy about the World Championship and the good business that they were making because Germany was doing really well and they were selling stuff like crazy. And so the users were extremely happy. But the CIO said, she said, we have not changed anything. So 30% improvement when it comes to user experience, that is not true. It's not there. It doesn't exist. So that was the interesting finding that we had when doing that kind of surveys. And I was standing behind many CAD/CAM users when doing benchmarking. And there was one guy in a company, and he had like the really beefy, high-end CAD/CAM workstation on his table, on his desk, and he was working on that, on some AutoCAD things. And then he said, hey, I have that other model I want to show you, and I'm going to connect to this other machine here. And I was looking at what he was doing. He was using standard RDP. And I said, what kind of hardware do you have in this other machine? Why are you asking? Because I have this beefy CAD/CAM workstations over the high-end graphics card. And look at the performance. And I was like, you're not taking any advantage of your high-end. You have a $20,000 CAD/CAM workstation, and you RDP into this shit machine down there. and now you tell me that you have an outstanding user experience? Give me a break. And it was interesting, and they didn't want to have VDI from their data center. I said, no, that's not going to work. I need local access. I was like, you have your mini data center under your desk, and you're using not the latest technology. And you're not taking advantage of the hardware that you have and the huge investment that your company has done for you. The thing was that the performance was really good because of the bandwidth that he had between those two. It didn't matter to him what the bandwidth was, and that was one of the critical factors. So when we're talking about providing high-end user experience from the cloud or from a central data center, we need to use GPUs. But there's a note down there. CPUs cannot compensate bottlenecks caused by network bandwidth, latency, or packet loss. I will cover that in the last 10 minutes of the session, just to make sure that you all understand what the impact is of these. Before I do this, we start with LAN scenarios and with scenarios with data centers that are close enough. So that's the idea. Good. So little Benny here on the left side wants to access high-end graphics applications that are running in a data center, and the GPU is in the server. Just to make sure that you understand, this GPU is in the server. If you have GPUs on the client side, yes, the protocol can take advantage of that. It improves user experience because then you do GPU-accelerated stuff on both sides. Now, every tablet, every laptop, even your smartphones, they have GPUs. You wouldn't be able to run YouTube videos on your smartphone if there wasn't a GPU or something that does the decoding of the video protocol. And that is the idea, the video format. And this is what the GPUs on the clients take advantage of when you're remoting. Now, there are dozens of popular graphics applications, high-end graphics applications. And I see many demos here where people show AutoCAD and Revit and all of that. The question is, what is the user base that use these applications? And on the other side, what is the user base for that? Like Office, the standard Windows, the browsers, Adobe, the Creative Cloud, all these things. I think there are many more users on this left side than there are on the right side. The question is, do these users on the left side, do they benefit from GPUs? Well, what I did is, and this is the only time when I'm talking about Lakeside SysTrack, because I went and took a look at how many applications in a customer environment are using either DirectX or OpenGL, because those applications can be GPU accelerated. You take it for granted. If you run them on a local machine, you take it for granted that these applications perform really well. Now, I looked at the larger environment, and oh my God, there were so many apps that were using either DirectX or OpenGL. That was an interesting experience. So there it became clear, okay, this is not a small niche market. This is like a mass market. And why is that? The standard settings that you find in Internet Explorer, that you find in Chrome, is use GPU acceleration. Windows 10 doesn't work without GPU. If you don't have a GPU, the GPU is emulated by the CPU. So the window manager works that way. The window manager always thinks there's a GPU. And if there's a physical GPU, performance is much better. You can try it out. You can disable the usage of GPU, and you see the difference. But not only for the browsers, Office. Office is DirectX. It takes advantage of GPUs massively. Yes, you can turn it off. Don't do it. You will not like it. I don't know why this was introduced. Probably because at the beginning it was a question of stability. You were able to turn it off if your PowerPoint crashed because you did something crazy with the graphics elements in there. And then you were able to turn it off. But it was not beneficial for the other applications or the other PowerPoints. Yeah, there was a question. Bad graphics drivers, that's a good comment. Yeah, if you have bad graphics drivers, you may want to disable GPU acceleration. Absolutely correct. So, and they have all these GPU manufacturers. Well, leading edge NVIDIA with the grid concept that they have. Today, the M60 or the M10, they have an entire software stack. Dedicated VRAM, shared GPUs, that is their concept. But you can also use it to pass it through to individual VMs. So we're going to cover that in a minute. You have AMD. They fell a little bit behind. They have great graphics cards, but they were suffering a little bit the last year or two. So they were not able to keep up with NVIDIA. Still, I have a high-end AMD graphics card at home, the latest one, and I have previous ones. And whenever I find some issues with an NVIDIA card, I start using a AMD card just to find out, is it the hardware, the driver, or is it the OS stack that's causing these problems? And Ruben, Ruben Sprout in the Netherlands, he did a lot of testing around that when he found like artifacts in TP5, Windows Server 2016 TP5. So he started juggling around with graphics cards and trying to identify, is it the driver, like you said, is it a crappy driver, or is it the OS stack? And Intel, that's interesting. So they're coming from the low end. What they do is they put GPU cores in their standard CPUs. I mean, high end for Intel is 72 cores, GPU cores now, which sounds a lot. But if you compare it to NVIDIA with like 3,000 cores per GPU, that's a different story. So CUDA cores, you have up to 3,000 CUDA cores per, or 2,500 per physical GPU. And you have cards where you put 2 or 4 of these GPUs on one PCI card. So this is the kind of graphics performance that you get with a server card from NVIDIA. These NVIDIA graphics cards don't have any video output anymore. So you have to make sure that you have a secondary card in the server, because otherwise if you activate, this GPU, fine, you're blind. You boot your server, but there's no way you can connect the console to it. It works, but you can't see it. In the standard server chassis that you get from the large vendors like HP and Lenovo and Supermicro and Dell, they make sure that you have this secondary card in there. Good, but that gives you a nice spectrum of what you can have. High-end NVIDIA and on the low-end Intel and AMD kind of squeezed between the two. But these are the hardware components that you can use for remote effects. Now, what is remote effects? So when I refer to a local workstation, I refer to the left side, direct map, bare metal. You have a Windows OS, you have a graphics card in the machine, and you have a driver delivered by the independent hardware vendor that lives in the OS. So either AMD or NVIDIA or Intel give you graphics drivers that you have to install on the OS. Software rendered, warp, there is no GPU in the machine. You can do that either with a bare metal machine or with a hypervisor. Like I said, from that moment on, the CPU emulates the GPU to make the applications think that there is a GPU. But a CPU was never designed for the work that a GPU does, because a GPU does highly parallelized work. This is why they have so many cores. Your CPU doesn't have those cores, those number of cores. So it's a multi-purpose processor. So that's the fundamental difference between the GPU and the CPU. The GPU is highly specialized on certain things. Now, if you use remote effects, what you do, you install the hardware-dependent driver in the hypervisor, and then you pass through GPU capabilities to the VMs, but they are using the synthetic driver that comes with Hyper-V. It's also called API intercept. Whenever you use a graphics API, it's intercepted and forwarded to the driver that lives in the hypervisor, and the hypervisor offloads stuff to the GPU to do the heavy-duty jobs. This is what RemoteFX is about. DDA is about punching holes in the hypervisor and allowing individual VMs direct access to the GPU, to one of the GPUs that's in there. If there are multiple GPUs, you assign one GPU to one VM. Again, this is the most expensive technology, as you can imagine. You're buying like a $5,000 graphics card with two physical GPUs, and you assign one GPU to one VM. So it's a $2,500 investment for that particular VM. Okay, so this is what DDA is about. DDA is based on SR-IOV, which in the past was used to expose network cards to VMs. And they extended this concept to like any PCI device, including graphics cards. So again, giving you the RemoteFX on the left side, you have your what's it called in Hyper-V? The parent partition. In the parent partition, there is the independent hardware vendor driver, the management OS, yeah. And it has the endpoint for the communication of the graphics information. So the synthetic graphics driver lives in the guest VM, and it communicates with the RDVGM endpoint that forwards all the information to the driver provided by the hardware vendor. This is what RemoteFX is about. On the other side, DDA, discrete device assignment. You punch the hole in the hypervisor, and then you install the hardware-specific driver in the VM, and the VM is able to use all the capabilities of the graphics card. It's not so easy to do that DDA thing. So only one of my servers in my lab is compatible to that because it requires the latest versions of the chipset, BIOS, the right BIOS settings. So it's really critical. This is the reason why typically this combination is only sold from the big vendors like HP and Dell and Lenovo and so forth. So the only machine that worked in my lab with that technology was my Dell R720 after I upgraded everything on it, like BIOS upgrade and flashing the BIOS, like cross your fingers, oh my God, is it going to work? And how to configure it. Yeah, it was interesting. I bricked Intel gave me one server to play around with it. I bricked it. I had to send it back. There was no way to bring this machine to life again. There was no reset possible. So it's very interesting. That was at the very early stage of that kind of technology. They said, no, we can't do anything. You've got to send it back. So I FedExed the machine back to Intel. And I have a reference server on the left side, this one with the EM60. I was not able to configure it so that it was able to use DDA. On the other side, the Dell with the Grid K2. Yes, it worked. You need to do it from PowerShell, like you identify the device, you disable the device, you dismount it so that it's not visible in the device manager anymore, and you assign it then to the VM. You need to know the name of the VM, and first of all, you need to identify the right device, because if you have multiple GPUs in there, each GPU shows up as an individual device. There's no UI so far. See the potential of the little community tools? PowerShell is our friend, and now we have like a framework to have a GUI. Whoa, wonderful. So this is sort of the thinking that we have, because Microsoft is really, really good at providing the PowerShell scripts. It's extremely powerful. But like I said, if you are a consultant, you go to your customer, you deliver the PowerShell script, you come back 5 days later, you don't recognize your own PowerShell script anymore. Okay, so there is a DDA.ps1 script by Ben Armstrong. Just search for it, because it's able to show you if any of your devices on the machine is capable of doing that. And then there's an RDS Gurus article where I walk you through all the different steps. And Chris Griffin, she helped me with that. We are walking you through all the different steps to do that, to enable DDA. Good. Who's using it? I mean, the designers, DDA, power users, knowledge workers, remote effects, API intercept, yeah. Task workers, okay, graphics rendered. On software, what are the numbers? So these numbers came from NVIDIA. They did a survey. And we're talking about 500 million users that potentially can take advantage of GPU accelerated or more. Yesterday, there was the session about GPU acceleration delivered by Microsoft. And there was a number like 20 billion revenue estimated in gaming, 6.5 billion in graphics workstations, and 8 billion in automotive alone. I mean, we're talking that we have a fragment of the market, and it's already a 35+ billion market. Wow. So this is why I said it's not a niche anymore. So we're not talking about, are we going to see GPUs in virtual machines anytime soon? No. It's a question about when are we going to see them in all of the virtual machines? Because we take it for granted with the laptops. We're going to take it for granted in virtual machines and remote desktops. So that's no question for me anymore. Okay, when you do benchmarking, you can either concentrate on end user experience. This is what we're going to do in the rest of this session, like baseline UX performance, standard load scenarios, separately testing for different graphics formats in order to find out if they work or if they don't. You want to have screen recordings, telemetry data, response times, and you want to compare visually. The other thing is system scalability. Yeah, find the saturation point. Find out what happens with simulated heavy workloads. When does your environment break? That is the idea of system scalability. Login VSI is the product of choice there. They are specialized in that. I was a member of the design team initially when Login VSI was created at Login Consultants. At that time, I worked at Login Consultants, and together with the CTO there, we created the initial architecture for this framework. But later, I concentrated more on end-user experience. And our friends from Login VSI, they cover one side of the medal, and we cover the other side with RDS Gurus and Team RGE. So that's how we work out there. And remote end-user experience, you need to look at the user interface response times, like how long does it take when the user clicks until there's a noticeable action, the refresh cycles, which graphics formats and media are supported. We want to see, well, what is the perceived performance? Are the media in sync? The question of lip syncing. You have seen that before when you see a video and sort of the audio track is like half second behind. That's very annoying. So you want to make sure that these things work, dropouts, blurriness, artifacts. So we are massively working with frame grabbers. Like I feed everything into the projector here. We do the same with physical frame grabbers, allowing us to record videos. The good thing is that they get cheaper and cheaper because the gamers use them a lot. And so you can get them for like a couple of $100 now, which used to be a very expensive device in the past. Today, you go to a standard supermarket and you can buy those frame grabbers for gaming purposes, and they encode in MP4 in real time. So that's very interesting because they want to show people on YouTube how good they are playing certain games. So this is and there's an entire industry around that. Like I said, 20 billion is the number that Microsoft gave us. Good. Now, how do you measure that kind of stuff? I have a lab controller at home that sits like the center of a spider web and controls the other things. So I have the host with the guests out there. I trigger the start of test sequences that run on the client. I have a recorder with a frame grabber that records everything. I also collect telemetry data and network information. I archive it, and then in the end, we put it into so-called 4-ups and run them. Good. Now we test it. The first thing is DDA on Azure N-Series, and we are using the NV6. This is the one that you have seen, those of you who came before the session started. This is what I was playing around with, and we're going to take a look at it. Prior to coming over here, Chris Griffin, she tested from Seattle, and she had 56 milliseconds latency. I had, at the time when I tested from my lab in Frankfurt, I had 138 milliseconds latency because we both connected to the South Central region Azure Data Center in Austin, Texas. So, and we recorded those. But for here, it's a lot more interesting showing you what the performance is when we connect from here. And this is what's running behind the scenes. So you see this is an NV6 in the Azure Data Center in Austin. And as you can see, almost. So now we can zoom in. And you see it's the NVIDIA Tesla M60 Plus with an additional adapter. Now you know why. And that's necessary if you want to do some maintenance. Okay, and we run this remote display analysis tool that gives us access to the information. How are we connected? Right now, it's TCP only, not UDP. The available bandwidth here in the wired network is 232 megabit. Wow, amazing. And right now, we're using pretty much nothing. When I start using the thing, like moving the window around, okay, now you see down here 1.3, 1.6 megabit per second. But it gets a lot more interesting when you start using real tests. Now, I have an interesting test here, like a Geek3D GPU test. If you run that kind of benchmarks, they are OpenGL benchmarks. And what they do is, they put load on your GPU. But if you look up here, we're working at 140 frames per second over in the data center. That's amazing. And, but we are only using 4.5 megabits right now. So that's interesting to learn how these things work. Now, if I run some of these tests that we do with our benchmarking framework, like I said, we have for all the different graphics formats, we have individual sequences. Now I want to run the Flash GUI mark. It's a Flash sequence in the browser. And just take a look at it, what is happening. Now I'm not touching it, so it's fully automated. So now it runs, and you see, wow, it's amazing performance, but it consumes lots of bandwidth. And at a point, have you seen, it reduced the color depth. So it adapted automatically. At the beginning, quality was extremely good. But then the protocol figured, oh, this is more like a video. So I used the video codec instead of the still image codec, because the still image codec would create bandwidth far north of 100 megabit. And then it dropped down to 6, 8 megabit per second. So the protocol is self-adapting. Now watch when it ends, and it creates 32 frames per second. At the beginning, the user interface was a little blurry, and it took like a second until the algorithm found out, the protocol found out, ooh, now it's still image. And still image needs to be clear. So I changed the algorithm, no artifacts anymore. You only can see that when you're recording videos. You can analyze them frame by frame by frame. And this is why we're doing it that way. It's like science. And so that gives you an impression of the things that we were doing. We were running through all these sequences. Here we have like a JavaScript that we're running in here, simulating a Ken Burns effect that is very resource intensive. Typically it takes a lot of CPU power, and because all this zooming into the picture and everything, that is what's happening here. Here we're only consuming like 5 megabit per second. All the heavy load is being done on the back end. Wonderful. So this is exactly what we want. This is why we have these GPUs. Good. Now, if I go and show you what it looks like when Chris and I ran that from our labs. Now we have 4 ups, so we are comparing these things visually. So on the left side, my Frankfurt data center access from there. Right side from Seattle. Down there, there's bare metal, Windows 10 in Chris's lab. That is our baseline. If we match or are better than her performance with a bare metal machine, we are where we want to be. And it's interesting, about 2 years ago, we started beating our high-end laptops with stuff that we had in our data centers, GPU accelerated. So yeah, we see, because we have 130 milliseconds latency, and we have to Frankfurt, and we have 60 milliseconds to Seattle, we see it stuttering every once in a while, but still performance is much better than I ever expected. Now you see the same photo gallery, and you will see the same thing. It's a little bit stuttering with the upper two videos, but not as bad as I thought it would be. So, really, really well. I was certainly surprised about that, positively surprised that it was so good despite the latency that we had. Now, looking at PowerPoint, doing the same thing. I created a PowerPoint deck that uses all these 3D effects, making heavily use of DirectX calls. And again, sometimes you see a stutter, but generally speaking, it works much better than I expected. It comes very close to the bare metal experience. So you see it here. These are complicated algorithms. So like here, you will see it like it stops a little bit. So it's not as fluent as it is on the local machine, but good enough for most use cases. Now, if we're doing a little bit more OpenGL, okay, so we will see now we are coming to the point where a local experience is still better. So this is affected by latency very clearly. So we want to be closer. This is why Microsoft wants to have data centers as close, less than 50 milliseconds latency to each potential user on this planet. That is the master plan. And this is why. You don't want to have latency. You can't beat latency. Einstein, it's Einstein's fault. Sorry about that. And we don't want to argue with him. What we also did, we compared Warp, no GPU, with RemoteFX GPU. Again, 4-ups, but this time we added the network information. So how much network is being consumed? So on the left side, it's Warp without GPU, so performance is not so good. On the right side, it's much better. And the surprising thing is, in this scenario, the GPU accelerated consumes less bandwidth. So the Warp was more chatty. This uses UDP. So we started using UDP here instead of TCP. Okay, so we found out there is a difference between using GPU and not GPU, even if we're doing it on the LAN. Let's do something that's a little bit more heavy. And here you're going to see it significantly what the difference is. This is a DirectX demo. So 5 frames or something on the left side without the GPU. We're talking about 400 frames being generated on the right side. Not all the frames make it to the end point. Most remoting protocols are limited to 30 or 60 frames per second that are being delivered to the end point. This may change as soon as you want to have, augmented reality. Because if it's so close to the eye, you want to go to like 90 frames per second and higher resolution. So we're going to need some more work in this until we are able to really use it in augmented reality scenarios. But we're getting there, very clearly. We're getting there. But it has a price. You see, 22 megabit peak, while on the other side it was like 3 megabit. But this is the difference in user experience that you get. And now we are using a WebGL, and that gives you an impression what the user experience is if one of the formats doesn't work. Because on the left side, you get an error message. Wonderful. This is the end user experience, while on the right side, yeah, GPU accelerated, it works. It is API intercept, but API intercept is good enough to deliver that kind of fidelity of that kind of user experience. Nope. You can't come in. Again, it has its price. Sure, it's 20 megabit when we're in a LAN scenario. But you have seen sometimes these protocols take even more. Now, Ruben did an interesting test because he said, hey, I want to find out how good one of those high-end benchmarks is. So he started Heaven on a VM, no, not on a VM, in a session with 1 gigabyte VRAM. Because VRAM is very important, the video RAM that you have. And in order to demonstrate what that means, I'm going to show you what it looks like on my laptop. Because I have Hyper-V installed here. If you look at the Hyper-V settings for this particular machine, you see that there are physical GPUs in there. There's one 4000M, which qualifies to be a GPU I can use for remote effects. So when I start VMs or when I configure VMs, I can assign this GPU to those VM on Windows 10. This is a Windows 10 machine, by the way. So you have access to this technology from a Windows 10 workstation if you have the right graphics card in there. Now let's take a look at one of the VMs. If I go to Settings, I can select the remote effects adapter. I add it, and here you can select what is the video RAM you assign to this particular machine. And this is what Ruben did. He assigned the top end, 1024 megabit, and then he wanted to compare what it's like if he assigns less. So the first test was with 1 gig, and now we are comparing Heaven running with 1 gig on the left side and with 64 megabyte on the right side. Now it looks like it's the same, so the picture shows up really quick, but then it starts loading, and now you will see the difference, because if you have more video RAM, you can put more objects in memory. So look at that. This is the difference in user experience. As soon as the elements, the objects are in the video RAM, everything is fine, but it had to cramp it into the 64 megabyte. And so this is the difference that you get. Now, it will also stutter as soon as it starts loading more objects. What we found out, if we run benchmarks that do not load too many objects, it's identical. So you have to make sure that the benchmarks that you're doing, the applications that you're using for testing, they represent the applications that your users are using, because this is identical. You can't see the difference. Because it's such a small number of objects, they fit easily in the 64 megabyte. This is why you can't see the difference. And that was also an important thing that we had learned. Good. So we're almost there. We're almost there. Let's switch back to the Prezo. As like I said at the beginning, impact of the network. We have bandwidth, you have latency, and you have packet loss. It takes 300 milliseconds halfway around the globe, and 500 milliseconds for a typical satellite link. This is the kind of latencies you get. And latency turned out to be more significant for performance than bandwidth. This is what we found out when we did the testing. And there's a good reason for that. There are latency effects. If you're using TCP, for example, if you introduce latency, it limits the maximum amount of bandwidth that you can use. So you see there's a curve. And this is why you want to use unreliable protocols like UDP that do not have this acknowledge handshake going back and forth, because they are more efficient if you have latencies. Yes, you will lose frames every now and then. So it will be stuttering if it loses frames. Fine, but these frames go away so fast, you don't need to resend them. It doesn't make any sense if you lost a frame and then you resend the frame and 2 seconds later it comes to the client. At that time, the sequence of, well, the video or whatever you run it's already at a very different place. So you don't need that frame anymore. So that is the thing that why you want to prefer UDP. Please configure your routers that they allow UDP. Otherwise, you're missing the boat here if you have latency in your network. And the same is true for packet loss. So now we have these curves with 25, 50, 100, and 150 milliseconds latency. Now we start adding packet loss up to 10%. And you see the bandwidth that can be accessed, can be used, goes down to like 0. And that is the reason. Even if you have a big pipe that goes from one place to the other, if you have latency and packet loss, you will not be able to use the bandwidth that you bought. So you're paying a lot of money for bandwidth, but then you're losing all the money because you have latency and packet loss. What we've done again, we've recorded that. These are the final videos that I have with me, because now we are running the most challenging thing to observe 4 videos side by side. Let me stop it. Top right corner, top left corner, LAN. Top right corner, 8 megabit per second, 50 milliseconds latency, but 2% packet loss. We're using physical WAN emulators for that. We're using APOSIT boxes. These are expensive. Wow, it starts at like $2,000, the cheapest one, and goes up to like, wow, I think 100K if you want to have the most sophisticated WAN emulators. But the hardware WAN emulators are a lot more accurate than the software WAN emulators. So all of the vendors, they asked us to use, they suggested that we use the hardware appliances rather than using software. Then lower left corner, 2 megabit per second, 50 milliseconds, and the right side, 2 megabit, 200 milliseconds. Now, we run fishbowl again, and you see, with 200 milliseconds, it's struggling, so it's stuttering. With the packet loss, you see, it's kind of smooth, but sometimes it stops. It loses the packets, it loses the frames, and then it has to catch up again. While LAN is very smooth. Now using something that is a little bit more demanding. And it shows you another thing that you should keep in mind. This is a DirectX sequence. And you see it says 300 frames per second or 200 frames per second. We all can see this is not 200 frames per second. It counts the frames that it renders in the frame buffer on the sender side. It cannot count the frames that make it to the end point. So this is why we're recording the video and comparing it, because these kinds of frame rates, they are lying. If you just take a screenshot and say, wow, look at that, 300 frames per second, the expectation on the end user side is, wow, I get like full performance, and this is what they get. Okay? So this is about expectation management. That gives you an idea what the effects are if you're introducing latency or packet loss. Final things, again, the PowerPoint. And now it repeats. It's always kind of the same effects that you will be seeing. So up here, it suddenly stutters. It is very fluent, and then suddenly it stutters because it lost some packets and has to recover and continue. While down here, you can even see it sometimes with the compression artifacts because there's not enough bandwidth available. I think it's even more visible when we do the castle. You see some of the, it's sometimes blurry on the lower side. It runs really nice. If you compare it to the ones that I had without a GPU, wow, look at that. I had a GPU in the, without a GPU in the LAN, I had like 2 frames per second. Now I'm using the same thing with 2 megabit and 200 milliseconds latency. It's amazing that I still have a good performance. So this is the advantage that you get with a GPU. Last one, the WebGL. But again, it's pretty much the same results. A little bit more stuttering up here, fluent for a while, then it stutters, and down here it is struggling. You see, fish are moving slowly. So that gives you an impression, and this is pretty much the end of my session. So, great RDS enhancements, performance, scalability, cloud. It's an ideal platform to build on top. Absolutely. Now, RDS is a platform rather than a solution. I really like that. Growing market for admin tools. Security, please keep it in mind. You have to do some extra work. It doesn't come out of the box. And GPU acceleration is something that we'll be seeing all over the place. Here are the links that I promised. So you can get the information and the tools that I presented here. So that is like the RD analyzer. Get in touch with the login VSI people if you want to do scalability testing. Yeah, there are nice tools out there. Get in touch with me if you want to go beyond that. And the last thing is, you know the IT Pro resources. And please, feedback is important. Evaluate the session if you liked it. Don't evaluate it if you didn't. Thank you so much.